Hello everyone and welcome to today's Power BI interview preparation session. In this presentation, we are going to cover two of the most frequently asked Power BI interview questions. The first question is about the fundamental difference between measures and calculated columns in Power BI, two concepts that are central to DAX and data modeling. The second question focuses on data transformation in Power BI, specifically what tasks you perform to clean and prepare your data before creating visualizations. These are must known topics for anyone preparing for a Power BI developer, business intelligence analyst or data analyst interview. So let's start it. Measures versus calculated columns explained. Let's begin with the first question. What are measures and calculated columns in Power BI and how do they differ from each other? Both of these are created using DAX, which stands for Data Analysis Expressions. Power BI's formula language, however, they are fundamentally different in terms of when they are calculated, how they are stored, and what they are used for. Understanding this difference clearly is extremely important for building efficient and well-performing Power BI reports. Let's start with measures. A measure in Power BI is a dynamic calculation that is computed at query time, meaning the calculation only happens at the moment a visual is rendered or a filter is applied on the report canvas. Measures are not stored as a physical column in your data table. Instead, they exist as a formula that Power BI evaluates on the fly based on the current filter context, that is, the slicers, filters, and visuals interactions that are active at any given moment. This makes measures incredibly flexible and powerful. For example, a measure calculating total sales will automatically recalculate and update its value whenever a user filters by region, product, or time period. Measures are the go-to tool for aggregations such as sum, average, count, min, max, and any other calculation that needs to respond dynamically to user interactions. Now let's talk about calculated columns. A calculated column is a column that you add to an existing table in your data model using a DAX formula. Unlike measures, calculated columns are computed at data load time, meaning the calculation runs when the data is imported or refreshed and the result is stored directly in the data table as a physical column, just like any other column in your dataset. Because they are stored in the table, calculated columns take up memory and increase the size of your data model. Calculated columns are best suited for row level calculations, situations where you need to compute a value for each individual row in your table, such as combining first name and last name into a full name column, categorizing transaction into price bands, or calculating the age of a customer based on their date of birth. The key difference to remember is this: measures are dynamic, they respond to filters and are recalculated on the fly, making them ideal for aggregations and KPIs in your visuals. Calculated columns are static. Calculated columns are static, they are fixed at data load time and stored in the table, making them best for row by row computations and creating new attributes that can be used for filtering or grouping. As a general best practice, prefer measures over calculated columns whenever possible because measures are more memory efficient and more flexible for interactive reporting. Now, data transformation in Power BI. Excellent. Now let's move on to our second interview question. What tasks in Power BI do you use to transform data for visualization? This question is testing your practical knowledge of the data preparation workflow in Power BI. Raw data is almost never ready for visualization straight out of the source. It usually contains errors, inconsistencies, missing values, and structural issues that need to be resolved before you can build meaningful and accurate reports. Power BI provides a dedicated tool for this purpose called the Power Query Editor, and it is the central hub for all your data transformation activities. Let's walk through the key data transformation tasks that you perform in Power BI's Power Query Editor before building your visualizations. The first and most essential task is data cleaning. Real world data is messy. It often contains null values where information is missing and duplicate rows where the same record has been entered more than once. In Power Query, you can easily remove null values by filtering them out or replacing them with a default value, and you can remove duplicate rows with a single click. Clean data is the foundation of any trustworthy report because if your source data has errors, your visualization will reflect those errors and lead to incorrect business decisions. The second task is changing data types. Every column in your dataset has a data type such as text, number, date, or boolean. Power Query automatically detects data types when you load data, but it does not always get it right. For example, a date column might be imported as text, or a numerical ID might be treated as a decimal number. It is critical to ensure that every column has the correct data type because data types affect how calculations are performed, how dates are recognized, and how visualizations render. Fixing data types nearly prevents many downstream errors in your text calculations and visuals. The third task is filtering rows. Not all the data in your source is relevant to your analysis. For example, you might want to exclude cancelled orders, filter out test accounts, or focus only on a specific time period. Power Query allows you to apply row level filters to remove irrelevant data before it even enters your data model. This not only keeps your model clean and focused, but also improves performance by reducing the volume of data being loaded. The fourth task is merging and appending tables. In real world scenarios, your data is rarely contained in a single table. It is spread across multiple sources such as different Excel sheets, database tables, or API responses. Merging allows you to combine two tables horizontally based on a common key column similar to a SQL join, bringing related columns together into one unified table. Appending allows you to stack two or more tables on top of each other vertically, combining rows from multiple tables that have the same structure, such as sales data from different months or regions. The fifth task is adding custom columns. Sometimes the information you need for your analysis does not exist directly in your source data. It needs to be derived or calculated from existing columns. Power Query allows you to add custom columns using its formula language called M, where you can write expressions to create new fields. For example, you might create a profit margin column by dividing profit by revenue, or extract the month name from a full date column. The sixth task is grouping and aggregation. When you have very granular transaction level data and you need a summarized view, for example, total sales per region per month, you can use Power Query's group by feature to aggregate your data at any level of granularity you need. This is particularly useful for reducing the size of large datasets by pre-aggregating them before loading them into the model. All of these transformation tasks are performed inside the Power Query editor, which is the central and most powerful data preparation tool in Power BI. It provides a visual step-by-step interface where every transformation you apply is recorded as a step that can be reviewed, edited, or removed at any time, giving you full transparency and control over your data preparation pipeline. The key takeaway from this entire slide is this: the quality of your Power BI report is directly determined by the quality of your data preparation. No matter how beautiful your visuals are, if the underlying data is dirty, inconsistent, or incorrectly structured, your report will produce misleading insights. Always invest time in thorough data transformation using Power Query before you start building your visualizations. Clean, well-structured data is the single most important ingredient for accurate and meaningful reporting. Thank you.